play on this one. This is we talked yesterday about synthesis reaction and decomposition, and this is all it's on. Decomposition, Santa's workshop. You don't care. Okay, got Santa's workshop. I want is Santa's workshop any good? I've never tried it. Anybody want to try that one? Hey Randall, how are you? There we go. So I've got Santa's workshop. I need at least one more to vote so we can break the tie. Well, IDK could be Santa's. I'm glad you're good, Randall. All right. So, what? Any more voters on what game we're gonna play here? We got fish. Oh, Santa's Workshop. Okay, looks like we're gonna do that. Okay, so let's do Santa's Workshop. Free until 12/18. Oh, am I a plus only? I don't know. Okay. Do we need to see how this works? All right, so let's do the toy ends after player reaches. Okay. All right, 7 minutes. Okay, so let's do that 7 minutes. Oh, it's not two. Let me get that link for you guys. And let me go back to the public chat. There is the link. Hey, Anilla. Oh, sure, no problem, Anella. Hey, Namara, good to see you. If you guys can get into the booklet there, it's on decomposition and synthesis reactions that we had yesterday. I see. Yeah, I didn't get. Were you working? Were you doing that yesterday? Because I asked you a question yesterday, you didn't respond. I was wondering if you were outside or something. Thanks, Liliana. Can't have that one in there, guys. I see. Do it. You're multitasking, were you? Who's Nick? Nique. Anybody? Want to respond who that is? Dominique, is that you? Oh, yeah, that makes sense. Yeah, thanks, Dominique. We got 22 people. This is on yesterday's assignment. We can get everybody in there. That'd be great. Come on, Janaya. Come on, Caitlin, Kalani, Caleb, Keon, Madison, Namara, Rainey, Tad, ZJ. Let's get in there. I'm joining. All right, thank you. Come on, George. Thanks, kid, for getting in there, Deborah. Ava. No, can't have that one either. Thanks, Janaya. All right, thank you. We'll get started here. Build toys. Answer questions, build toys. Put this on pause. And just 34 seconds left. Janaya is in the lead. Wow, Janaya, you got a real big one there. So this was just on decomposition and synthesis, and hopefully you can tell the difference. One's the opposite. of the other. So one takes two or more things and makes one product, and this one, and the other one is has a product and breaks it down into more. So, all right, 5 seconds. Four, three, two, one. All right, final standing. Janaya, how did that happen, Janaya? DJ, oh my gosh. Wow, way to go. All right, ladies and gentlemen, let's go over here. So this is the module today. We have a couple things we're going to do. So here is the assignment for today, the participation assignment. It's a little bit different. I'm going to try this. It's 12 types of chemical reactions. We're going to talk about more chemical reactions here. It's a Google Doc you can hand in to me for bonus points. But here it is. I will link this to you. All right, and I have the slides as well. So, and this will be in the shared documents as well, shared notes. So what I hope you guys will realize is that you should be able to, all right, you should be able to do this assignment. If you look at the modules here, you have in week 17, right? Here we go. You've got a graphic organizer and the notes, all the notes here, types of reactions. Hey, that's okay, Shay. It happens. It happens. So here are the slides that go along with that. All the slides. I broke them down into smaller punks, smaller pieces here. All right, so let's take a look at what we're doing today. So I'm going to turn my camera off so we can see this in bigger form. So yesterday we talked about synthesis reactions, but balancing equations is still the thing that we did last week, and I know you guys didn't get a lot of help on it, but I just wanted to go over the law of conservation of mass, that products are equal to the mass of the reactant. So here we have an unbalanced equation. We have 4 phosphorus, 2 oxygen, 2 phosphorus on the product side, and 3 oxygen. All right. So we want to be able to balance this. So let me ask a question here. If I can cut the chat here for a minute, I'm going to clear the chat and I'm going to ask a poll question. All right, I'm going to put a 2 somewhere, start a poll, publish a poll. All right, where should I put a 2? Where should I put a 2? 2 to balance this equation. Where should I put 2 to balance? To balance of those 3 things, type for me where you think they should go. BALANCE. Type a question. So is it P4, the first one in the reactant side? Is it O2 or is it P2O3? Where do you think we should go? Start the poll here. Where do you think we should go? I really appreciate when the people are getting in there. Hey, Serenity. Ah, very good. You got it. Put that in the poll. Put that in the poll. All right. I got some people saying O2. All right. Thanks, Janaya. Thanks, ZJ. Serenity, thank you. Everybody else? Anybody else in there? All right. All right. I got Jasmine and I got Shay and I got anybody else? I've only got one person that has the right answer. So only one person's got the right answer so far. All right. We got 6 responses out of 24. So it looks like people are pretty uncomfortable putting themselves out there in the land of bonus. All right. So, okay. So here is, I'm going to show you this is where I'm going to put the 2 right there. So if you're doing this with me, put the 2 there. So this will make this, because it's heavy on the reactant side, we're going to make this. So now we have 4 And we have 6. Okay. So I'm going to ask another question here, type response. Where will I put the 3? Where do I put the 3 there? It's either P4 or O2. P4 or O2. Where am I going to put that 3? It's either P4 or O2. Let me know. Hey, thanks, DJ. I appreciate it. Thanks, Jasmine. Okay, I got 2 votes out of there. Out of people, you got it, Serenity. Yep, you have it. All right. Okay, so I got, all right. So most of you guys have it. It is publish a poll. This is where we are right here. This 3 fixes this oxygen. So we had 6 oxygen on this side, so we had to go to the reactant side to make that 6. So 1, 3, 2 works us out. Okay. So yesterday, we talked about synthesis reaction. A plus B equals AB. All right, so let's do this one together here. So not Barney, Fred and Wilma separate, but when in the product side, they become a couple. So, all right, so we're going to arrange this. Let's put this one on top of here. Let's do the synthesis reaction here. All right, so anybody want to show their screen and figured out how to put a synthesis reaction, let me know. I'll give you a minute there. If you're participating, you can show your screen on with the synthesis reaction. If you've got it all figured out, let me know. Okay, and I will let you show your screen. Let me know in the chat as well that you're ready to show a screen. I don't really have a lot of participation today. I'm not sure why. It might be that we're close to the end of the marking period, or it might be because just tired. It's early in the morning. There's a lot of work. You got 5 hours and you started off tired, didn't have your breakfast. I didn't have my breakfast either, but I got up and exercised this morning. All right, ZJ, thank you. All right, let me give you share your screen here. Let me go. Where are you? All right, share your. Okay, so I'm going to make you the presenter. Okay, there you go. All right, so share your screen with me and see how we did here. So we're doing the synthesis reaction. You got it, man. That is perfect. Yeah, 2 things make 1. All right. Excellent. Can you hit the share button or the slideshow button on yours? Oh, too late. I was going to see if anybody else had that there. You got a great job there. Did a great job there. Yeah, there you go. There you go. There you guys. If you're doing the assignment, ZNO plus CO2 gives you ZnCO3. Thanks, Janaya. That is so nice for you saying that to ZJ. So supportive. I appreciate you guys being supportive. All right. Okay. Thanks so much. All right. So so let's go to the decomposition one. Can anybody do, oops, I'm going to go share this one. Can anybody share the decomposition one with me? And show me what that one looks like. Remember, the decomposition is AB gives you A plus B. So if anybody's interested in sharing that, what there's, oh, okay, thanks, Serenity. That is so nice of you to do that. All right, it keeps me from having to be the only person that's showing their stuff here. There you go. All right, so remember the decomposition is the exact opposite of the synthesis reaction, right? The exact opposite. Did I do it for you, Serenity? I'm sorry. I might have picked the wrong person. I hope not. Might be just taking it. There we go. Exactly. Okay. Can you hit the slideshow so people can see that really good? Hit the slide. Just hit your slideshow button there. It's over up by the share button. Just hit the slideshow and it'll make it bigger. It's over the right hand corner. Just yeah, big white button that says slideshow, and then the blue button that says share. Okay. Not a problem. So you got ZnCO3 yields ZNO plus CO2. Excellent. Thank you, thank you, thank you. All right. All right. I'm going to take the presenter back. Let me go back here and get my slideshow. All right. Okay. So we did those two slides there. Okay. So just review. So today's assignment, we're going to go again to talk about the types of reactions we did yesterday, and some of you weren't here yesterday, so we did the synthesis and the decomposition. Today we're going to do single and double replacement. All right, and certainly, and then we have one final one we'll do on Wednesday. Okay, so let's take a look at single displacement or replacement. We can use replacement as well. Replacement. Okay. Replacement. So we have an AB. So we have a compound here. Okay. And over here, we have an element or another compound. It's usually an element. Okay. And then what happens is that element kicks out. So C kicks out B. All right. So C kicks out B, and B is set by itself. So the zinc kind of kicks out the hydrogen in here. So now it's ZnCl2, and then the H is separated. So a single displacement reaction looks like that. So we think about it in terms of Fred and Wilma, and then Betty comes by, and then they switch. Fred and Betty are talking, and Wilma's by herself. So we have a couple, we have a single element, and then we switch places here. Okay, so this is what we do with this one. Okay, so that's a single replacement. So here's a single replacement. Okay, we've got an Mg and then MnO3. So I can switch them. I don't necessarily have to have the Mg second. So this is an element. And then we have a compound. And then on this side, the Mn gets kicked out, and the Mg takes over the MgO. Okay, so this is an assignment. If you're going to hand this in, I'd like you to balance this equation. Okay, so balance this equation. Okay, you can, when you do this, escape, you get to click on the numbers here and then put them in. Okay, so this is your, if you want some bonus points, finish that up for me. Okay, now let's take a look at the next one. This is called double replacement. All right, so you have two compounds in this particular case. Two compounds. Let me get the pen here. All right, so compound 1, C1 and C2, and notice it A goes with C and B goes with D. So here magnesium chloride and sodium fluoride. So the sodium goes with the chlorine and the magnesium goes with the fluoride. So it switches places. So you can tell this is not a synthesis reaction because remember, synthesis is A plus B gives you AB. We can definitely tell it's not a synthesis reaction because we should have one thing here. It's two things gives us one thing, gives us two things, right? So this is not a synthesis reaction. It's also not a decomposition reaction. So AB gives us A plus B. So it's not that. You can tell that because you got two things over here and you got two things over there. So here it's one thing gives you two. Here is two things give you one. Two or more actually gives you one. So we can always tell, right? And let's use Fred and Wilma and Barney this time on our next one. Okay, so here we go. Double replacement. Fred and Wilma, Barney and Betty. Now Fred and Betty and Barney and Wilma. So we're taking places, switching places here. Okay, so here is another one you're going to be doing on your own. You're going to balance this. This is a double replacement. Ag goes with the OH. Li goes with the NO3. Velma. That's okay. Velma. Yeah, it does sound like I was saying Velma. I was hoping I got this. So you're going to balance this out for the extra bonus points. Balance it out for me. All right. So like you guys to figure out, let's go, let's do this in a escape mode here. All right. So this is A, B, C, and D. So let's talk about the double replacement. Okay, so let's see if you guys can find out where the double replacement is. So this is, let me see what slide this is. Escape. Okay, escape. Boop. This is slide 14. Okay, slide 14. Let me go back to slideshow view. Oh, it took my letters off here. All right, so let's do this. This is A, B, C, and D. Okay, in the poll, which is the double replacement? See if you can figure out the double replacement or displacement, either one. I like to say replacement. One replaces the other. A, B, C, or D. Okay. Start a poll. Right. Okay. There's probably a couple of them in there. There's single replacement or double replacement. There are two of them in there. So which one do you think? Which one do you think? All right. So thanks, Deborah, for getting in there. ZJ, thank you. George, thanks. Leah, good job. Cheyenne, Bugs, thank you, thank you, thank you. And who else do we have? Cece and Shay and Jada, Leah. Okay. So we've got two choices here. So we got almost half the class. That is fantastic. You guys are excellent. Okay. So most of you said A or C. Okay. And so A is correct. AG took over with the CL place and K went to, so this is a double replacement, they said a double DD, double displacement or double replacement. And some people said C, that's correct. MGO becomes CAO and MGS became, so that's two places. So that's a double. And then you can definitely tell that this is a single replacement because you just have the K by itself and the CL by itself. You have an element by itself. This is a single displacement or replacement as SD, single displacement. Displace, like I've displaced my keys or I've moved my keys or something like that. That's what happens. All right. So let's take a look at what we got today here. Okay. So let's just go over review here. Okay. Synthesis, A plus B equals AB, right? Fred and Wilma, or Velma. I like Velma. Gives you separate, but then they become a couple. That's your synthesis reaction. Decomposition, AB yields A plus B. So we're breaking it down. We're taking one thing, a compound, and breaking it to elemental parts. All right, decomposition, Fred and Wilma are a couple, and they separate. All right, so let's take a look and see what we can do here. All right, so I'm going to help you guys out on this one. All right, so I'm going to ask somebody to show their screen. I'm going to click on escape. Okay, we haven't talked about this one, but this is combustion right there. Okay, when you get this one done, I will take a person to show their screen. If you could do that, show your screen. Are you already done, Serenity? Ah, okay. Okay. Alrighty. Let me give you um gee, was a quicker trigger there, ZJ. You wanted to show yours too. Thanks for wanting to do that. So all right, I'm going to make you the presenter there. See if you can figure it out. Thanks, Serenity. All right, decomposition, correct. All right, and oh, thanks. There you go. Double replacement, double displacement, and then synthesis, and then single displacement. Yeah, excellent, excellent. You did a great job. Thanks so much, Serenity. Okay, so here's what we are doing today, ladies and gentlemen. So I am going to, okay, so you have two choices or more than that. So most of you did not do the W16 balancing equations. You should be able to finish the W17 assignment 1 types of reaction. It goes over just synthesis and decomposition. So you should be able to do that. So you can get started on this one, right? This one, I'll be doing some work with anybody that wants to do this one in the breakout room. So if you're interested in doing this one is actually points here. This one is an assignment. This is not bonus. This is 15 actual points. Okay. Right. Same as this one. This is 15 points as well. So I'm going to work in a breakout room with people. If they want to, just let me know. Again, no one in this class has done this assignment. So you have a choice. Do this on your own. Okay. Or in a breakout. If you want to do this in a breakout room with me, come and just sign up or say that you're interested in the private chat. Okay. You just need help with the W16. What's INA? Which of the W16 is it? Oh yeah, yeah, yeah. Let's do that. If you're interested in doing that, let's go into breakout room. Okay, no problem. All right, thanks, Shay. Okay, so anybody else want to get into the breakout room? Let me know. Okay, I'm going to do that. I'm going to pause. All right, ladies and gentlemen, you are free to go. No, you don't have to do the rest today, ZJ. You got until January 11th, actually, right? So you've got time. It's overdue. That's all it is. It's just overdue. Okay. All right, guys. Thanks so much for coming in. All right. I will talk to you tomorrow, Same time, same place, same station. All right, bye bye.